Hi! So today we're gonna talk about moles and how we use them in daily life. Kuba is feeling really tired after a 10K run. Let's help him out. Let's get Kuba some water. Many people, water is just from the tap, filling the mug from the tap. However, when you want to take this to the next level, you have to consider moles. A mole measures how many atoms we have from an element or compound.
So 1 mole is equal to a big number.
It's actually a really big number.
To be more specific, 1 mole equals to 6 times 10 to the 23rd power of atoms. We all know how much water we're putting into the mug, as in for milliliters. However, we know that water is made of hydrogens and oxygens. So what if we want to measure how much of each element we need to fill up that mug?
Yeah.
Imagine that we have 250 grams of water in the mug. Let's work out the moles. To figure out the moles, we need to get the mass of water divided by the relative molecular mass. Don't be scared if you get a really complicated number, because it's how much moles is there in 250 grams of water. Next step, let's look at the equation to make water. So now we need to take the equation of water and balance it. So we got 2H2 plus O2 equals to 2H2O. In the balance equation, the big numbers are the numbers of moles.
So you may remember our big number from earlier that was the amount of moles in that 250 grams of water. The next step is to change the equation so that the big number before H2O at the end of the equation is the same as the number from before. That way we know that the amount of moles in the equation is equal to the amount of moles needed to fill that 1 mug of water. What we had to do was find a number that we could multiply by 2 in order to get our previous number from before. And that number is this. So all that's left now is to multiply the entire equation by this number, and then we'll know how many moles of each individual element we need to get the amount of moles for the total mug of water. So after all of this, we found out that we have a roughly 14 moles of hydrogen and about 7 moles of oxygen coming together to make our 250 grams of water. But there's one last step. If we want to find out how much of each element we want, it's much easier to put this into grams. So once again, we need to go through another formula to put moles back into grams. So if we want to find out how much of these elements we need in grams, we can take the relative atomic mass, or the relative molecular mass, and multiply that by the moles, and that gives us the mass. So in the end, we have roughly 27.7 grams of hydrogen in the water, and we have 222.222222 grams of oxygen in the water. That might seem like a lot of 2's, and there's one way to check that this is correct. If you take the mass of the amount of oxygen we have and the mass of the hydrogen, add them together on your calculator, and you will see that it comes up to 250 grams, which is exactly the answer that we had at the beginning. No.
Ja so Mariano!
See? No, you fucked. Oh no. She's actually.
As you can see, Kuba's being very salty after losing to that table soccer game. So she's so salty that he can fill up the entire salt container in the school cafeteria. Do you want to figure out how much salt he has?
So if there's 75 grams of salt in the salt shaker, by using salt's molecular mass, we can find out that there's this many moles of salt. Once we balance the equation for salt, we now need to change the coefficient for NaCl. So if we multiply the equation by this number, that means we'll have this, if we add up the number of moles of each element, we'll have the same amount of moles of salt that in the salt shaker.
Yeah.
Now that we know how many moles of each element there are, we can multiply that by the molecular mass of each element to find out how many grams of each element there is. This leaves us with 29.5 grams of sodium and 45.5 grams of chlorine in the 75 grams of salt.
Exactly.